Okay, activity 7.3, this is called Which One? It says, here is a grid showing triangle ABC and two triangles. This is triangle ABC and your two other triangles here, okay? You can use rigid transformations to take ABC to one of the other triangles. Which one did you choose? Did you try your different moves, or did you just take a... Some of you probably could have looked and just saw your answer right off, because remember what a transformation is? A rigid transformation doesn't change the size of the side lengths. They have to stay the same. Side lengths must remain the same. In other words, if from A to B it's 3, your other corresponding angles also has to be 3, okay? So if you looked at this one here, this would be your corresponding side because this is the shortest length. You'd have 2 there, okay? Because this one did not preserve the side lengths, although the angles are the same size. You could check that with your tracing paper because this is a 90 degree and then you could have checked the others using tracing paper. But because the side lengths are not the same, I would have to say that right here would not make it. Okay, so the only other choice that you had left would be your triangle CFG. Okay, CFG would be the same because remember it keeps the same sides of the side lengths, and you could also trace your triangle on tracing paper. Then you could have seen it was the exact same size. Okay, so if you looked at again with tracing paper. Yes, the angles are the same size. Angles are all the same size, but because it does not keep the side lengths, that means rigid transformation, okay? So the only one that would be a rigid transformation would be triangle CFG, okay? Because it preserves lengths, it remains the same size, and the angles are also the same size, okay? All right, so then the next part says here, trying to get this even for y'all. There we go. It says describe a rigid transformation that takes ABC triangle that you selected, which we chose the CFG. Okay, so would it take? Can you do it in with one transformation? Can you do it with just one transformation? Did you try it? I bet you most of you said it was a reflection, didn't you? Because you said, okay, if I reflect this because it looks like it's going in the other direction. So let's try reflection to see if it works. So if we trace our triangle, and I bet most of you said you would flip it over this line right here, right? So let's try that. So if I just flip it over that line right there, see what happens? It's not a reflection. And some of you may have said it was just a rotation. Well, let's see if just a rotation would work. Let's line him back up here. Whoop. Got him going wrong. Whoop. Got him upside down. There we go. That'll work. So if we did it around point C, and if we rotated him at any point, he doesn't ever line up. So even if we go counterclockwise, see what happens, it doesn't work. Then if you tried a different point, if you chose B, it wouldn't bring him over far enough. And then with A, it wouldn't bring him over to the correct spot. So if you looked at it, if you rotated around either direction, it would not bring you to that figure. So, you can't really just translate it either. You can't just translate it over there because remember, like using a straight line, and see that wouldn't work. And if you move it down, so it's going to be more than one transformation. So I would say it would have to be a sequence of transformations. Remember, when you do one or more sequence of transformations, okay? All right, so did you try something that you thought worked? So once again, I put my little traced angle up, and I lined it up real nice. And the first thing I did was I figured out what my center was going to be because I'm going to do mine. So I'm going to rotate around center A up here, and I'm going to rotating 90 degrees. I got mine nice and even on a paper, so I know that one turn on my paper would be 90 degrees. So I'm just going to go like this. Then I'd have my A, and I'd have my B here. I can draw it out here. Just keep my line here so I know where it's at. If I draw him here now, I could connect my points. It'll just be like here. And there it is. I can see it. So it'll be like right here. Then I would just say, oh, it didn't connect. There we go. And I would say that this would be A, this would be prime B, and this would be prime C. Okay? But it's not there yet, is it? So I'm going to do one more move. And remember what a translation is? I can translate in a straight line. So if I took my, I can see going from B to F would be a straight line. So that's all I'm going to do. I'm going to just translate my B to my F over here, and they all line up real nice, okay? So that means I would say I used a, described a rigid transformation that would take it. I would say I would do a rotation. And remember, when we do, we have to know the center, and we use center C, about center C. And what else do we have to know? Oh, we had to know the degree of the angle. So that was a 90-degree angle, because we just moved it one time, and you can measure it too if you wanted to. And it was a clockwise direction, okay? 90 degrees clockwise, okay? And did a translation. Remember what you have to know for translations? You have to know the distance and the direction, right? So we already shot, and we can just say we translate, oh, gotta spell it right. Translate B to, okay. All right, so I think that's the end of this activity. So please make sure you put this in your book. I told you previously, I will be collecting your books to make sure you're doing everything. Good notes, because you will be having a quiz pretty soon on lessons 1 through 6, and you're going to want to have notes to go back and study, so make sure you're doing the right thing. Okay, so after you put all your answers in the book and make your corrections, you're going to hit the next button and go to your lesson summary.